We've had a look at Newton's second law, which is F equals ma, and I've written a form of that here, and at this block that I've drawn, we have F of gravity, the force of gravity, equals ma, where a is the acceleration of gravity downward. So there's Newton's second law. One of the most important forces that we discuss in terms of solving kinematic problems and motion problems is the friction force. We're going to do this twice, so you can kind of sit back and not worry about taking notes or understanding everything, because I'm going to start again and sort of do this lecture twice in a row, because there's so much going on, you kind of need time to absorb it all. So here's a level surface and a mass sitting on the surface, and that's a little symbol for the center of gravity, like they put on the crash dummies. So it looks something like that. And we assume right now, until we get to torque and rotation, we assume that all masses behave like their entire mass is concentrated at one point. So every mass is really a point mass. All of the force is centered at the center of gravity marker. And the green force is me pulling on the block. And remember, friction always fights us and opposes us in the opposite direction. And it is equal to the force of friction is, I say less than or equal here for a very important reason, because the static friction force starts out at 0. If you don't push against something, it doesn't push back. Remember Newton's third law, for every action there's an opposite and equal reaction. If you don't push, there's no static friction back at you. But if you have a large force pressing the block and the ground, or the two pieces that are moving, if you have them pressed together, that's called the normal force, where normal, doesn't mean, not that kind of normal. Like, wow, he's a weird uncle. We mean normal, like perpendicular. So I make the perpendicular sign. The normal force, or F with the perpendicular sign, times the static coefficient of friction, which is always larger than the moving one, because it takes more force to get something moving than to keep it moving. But the static friction can put up as much force as the normal force times the static coefficient. So if I'm pulling with, say, 100, if the mass of this block is 200 kilograms, or sorry, 20 kilograms, then M, which is 20 times 10, which is G, gives me 200 newtons of normal force, perpendicular to motion direction force. And if I multiply that by the static coefficient of friction, 0.5, I get the maximum amount of static friction force, which is 0.5 times 200, half of 200, which is 100 newtons. So if I go and I pull with 20 newtons, it'll pull back with 20 newtons. Not 100 newtons, because if I went and pulled something, it doesn't throw me across the room. It's an equal and opposite reaction. Once I get to anything slightly over 100 newtons, then I have to go back and use kinetic, because the maximum static force is going to be, for friction, is 100 newtons. So if I pull with more than that, if I pull with 110, now I have to go back and use the kinetic friction guy, and say that the frictional force is no longer half of 110, or 55 newtons, it's a quarter of 110, or 27.5 newtons. So we think about the static friction force as having a maximum value that's proportional to the normal or perpendicular force, which is weight on a level surface. And remember, friction always opposes motion. It fights you, pulls against you. And to figure out the normal force, which is sometimes written as an up arrow instead of a down arrow for every action and opposite and equal reaction, it's okay to draw the normal force up or down, is mg on a level surface. It's mass times gravity. So that is sort of the intro. We want to figure out if our pull force is enough to get the block moving. And if the block starts to move, we have to recalculate the friction with the lower moving mu sub k, mu kinetic. So the first question is, with a given force that I'm pulling on against this block, will it move at all? Anything under 100, it won't move. 90 newtons, it'll pull back with 90 newtons. 95 newtons, it'll pull back with 95 newtons. Don't pull on it at all, it won't pull back against you. 2 newtons of force that way, 2 newtons of force this way. But you break that 100 Newton mark, that half of mg, that half of 200 for 100 newtons. You pull with more than 100 newtons, you have to go back and recalculate the friction with the kinetic coefficient of friction. And the force of friction is always mu times the static force. Force of friction is mu times static or kinetic, either one, times the force that is perpendicular to motion. That's my big equation. So consider that, think about it, and we'll sort of run through it again by redrawing this and doing a couple of more examples. I think that will help you. So cogitate for a moment about it and then watch the next video.